Namaste, my dear students. How are you? Dear students, under electricity lesson, in previous class we are discussed about the factor affecting resistance, and we had also conducted a small experiment on that, isn't it? Yes. Today I am going to talk about the classification of the things based on the resistance, okay, and also the combination of the resistance in a circuit, okay. On the basis of electrical resistance, we can classify all the substances into three types. One is good conductor, another one is resistor, third one is insulator. We already know what is good conductor. Those substances shows low electrical resistance. Those substances shows low electrical resistance are called good conductor. For example, silver, copper. That means they are good conductor. Why it is good conductor? They allow the current themselves. What is resistor? What is the definition of resistor? Those substances which shows the properties of comparatively high electrical resistance. Those substances shows comparatively high electrical resistance. They are called resistor. Example is nichrome. And insulator. What is insulator? Once again, those substances which shows infinitely high electrical resistance. That means they are bad conductor. They are also called as insulator. They doesn't show any type of electrical flow of charge. So insulator ಅಂತ ಹೇಳಿದ್ರೆ ತನ್ನ ಮೂಲಕ ವಿದ್ಯುತ್ ಅನ್ನು ಯಾವುದೇ ಕಾರಣಕ್ಕೂ ಹರಿಯಲಿಕ್ಕೆ ಬಿಡದೇ ಇರತಕ್ಕಂಥದ್ದು ಬ್ಯಾಡ್ ಕಂಡಕ್ಟರ್ ಅಂತಲೂ ಕರೀತೇವೆ. ವಿದ್ಯುತ್ ಅವಾಹಕಗಳು ಅಂತ ಕರೀತೇವೆ. ಗುಡ್ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಸ್ ರಬ್ಬರ್ ಮತ್ತೆ ಪ್ಲಾಸ್ಟಿಕ್. It does not allow the flow of current. Now, we are talking about the resistance or resistors of the conductor or circuit. Apart from the potential difference in a circuit, current flowing through a conductor depends on resistance of the circuit. So, resistance can be connected in two ways. One is lengthwise, that means series, or we can connect the resistance in parallel. Then we get required current in a circuit. So there are two types of connection or combination of resistance in order to get a required resistance in a circuit. One is parallel connection, another one is series connection. Now let us discuss about two combination of resistance, and this is very important on the examination point of view. combination of resistance. There are two types of combination of resistance. One is series connection. Second one is parallel connection. Now let us study what is series connection of resistance. The series connection. Connection of resistors or RS. Suppose if you take three resistors R1 and R2 and R3 connected end to end, they are connected end to end. This is R1, R2, R3. Three resistors are connected end to end. One end of the series is connected to terminals of the battery, which is voltage supplier. Another terminals of the series connected to another terminals of the battery. Voltage is applied. Now the current flowing through this series is same. The magnitude of the current flowing to each resistor is same, but voltage passes across the each resistors is different. That means voltage is dropped but current will not drop. The same magnitude of current is passes through each resistor. Now I apply Ohm's law. According to Ohm's law, V is equal to Ri. So now I supply V volt, some amount of volt. So here V is equal to Ri. The voltage across the each resistor is dropped. When the voltage of R1 here, see, V is equal to V1 is equal to R1 I. Here in voltage of R2 resistor is V2 is equal to R2 I. Here V3 is equal to R3 I. That means voltage, a total voltage V is equal to V1 plus V2 plus V3. According to here, V is equal to Ri. I substitute the value Ri. Here V1 is equal to R1I. Here R2I. Here R3I. I remove the I. So here also R1 plus R2 plus R3. I get cancelled. R in series is equal to R1 plus R2 plus R3. So R in series is equal to R1 plus R2 plus R3. That means the combined resistance of any number of resistance are connected in series is equal to the sum of the individuals of the resistance. That means Rs is equal to R1 plus R2 plus R3. See, then so second one, parallel connection. R in P. Suppose if you take three resistors R1, R2, R3, they are connected in parallelly. R1, is R1, this is R2, this is R3. Okay. So these three resistors are tied one end. Other three ends are tied to another end. These two knot is there. No, it is connected to the terminals of the battery. Now the voltage across each resistor is same, but current passes or flowing through each resistor is different. That means current is dropped down, but voltage will not drop. So voltage across each resistor is same, but current is different. So current here is I1, in this resistor I2, in this resistor current is I3. That means total current through circuit I is equal to amount of current passes through here is I1, I2, I3. When we apply Ohm's law of equation, we already know V is equal to Ri or I is equal to V by R. What about here in this resistor? ಇಲ್ಲಿ ಏನಾಗ್ತದೆ ಈಗ ಇಲ್ಲಿ I ತಕೊಳ್ಳೋ I1 is equal to V by R1 here in first case. Here in this case I2 is equal to V by R2. Am I right? In this case, second one, third one, I3 is equal to V by R3. Am I right? Yes. If you supply the values to here, I is equal to V by R, then I1 is equal to V by R1, V by R2 plus V by R3. Okay, now I take a common factor V, 1 by R is equal to here V 1 by R1 plus 1 by R2 plus 1 by R3. Why? ಯಾಕೆ ಎಲ್ಲ V ಅನ್ನು ಕಾಮನ್ ತೆಗೆದಿದ್ದೇನೆ, ಆಯ್ತಾ? ಕಾಮನ್ ತೆಗೆದಾಗ ಇದು ಗೆಟ್ ಕ್ಯಾನ್ಸಲ್. Now R in parallel, am I right? So R in parallel be equal to 1 by R1 by 1 by R2 by 1 by R3. The reciprocal of equivalent resistance in parallel connection is the sum of the reciprocals of individuals of the resistance. That means 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3, like that. Suppose I want to get more resistance by taking these three resistors, or I want to less resistance by connecting these three resistors. What type of connection we have to opt? ಯಾವ ತರದ ಕನೆಕ್ಷನ್ ಅನ್ನು ಹೋಗಬೇಕು? ಹೆಚ್ಚು ರೆಸಿಸ್ಟೆನ್ಸ್ ಪಡಿಬೇಕಾದ್ರೆ ಅಥವಾ ಕಡಿಮೆ ರೆಸಿಸ್ಟೆನ್ಸ್ ಪಡಿಬೇಕಾದ್ರೆ ನಾವು ಯಾವ ರೀತಿಯ ರೆಸಿಸ್ಟೆನ್ಸ್ ಅನ್ನು ಆಯ್ಕೆ ಮಾಡಿಕೊಳ್ಬೇಕು ಅನ್ನೋದು. ನಾವು ಐ ಆಮ್ ಟೇಕಿಂಗ್ 3 resistors having a value 1 ohm, 2 ohm, 4 ohm connected in series and parallel, and calculate the net resistance. At that time our doubt is to be clear. Okay, let us do it. Now I take 3 resistors R1, R2, R3 having a value 1 ohm, 2 ohm and 4 ohm. According to series connection, series is equal to R1 plus R2 plus R3. That means R in series is equal to 1 plus 2 plus 3. That means R in series is equal to 6 ohm. That means the net resistance in a circuit by connecting 1 ohm, 2 ohm, 3 ohm resistors in series is 6 ohm. We get 6 ohm resistance. That means if you connect the resistance in series, we get the maximum resistance of the individual resistance what I have taken in the series. ನಮಗೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಸಿಗ್ತದೆ. ಅದು ಇಲ್ಲಿ ತಗೊಂಡು ನಾವು 2 ಓಮ್ 3 ಓಮ್ 4 ಓಮ್ ಅದಕ್ಕಿಂತಲೂ ಜಾಸ್ತಿ ಆಗಿರೋದು ಸಿಗ್ತದೆ ಅನ್ನುವಂಥದ್ದು. ಸಪೋಸ್ ಸೇಮ್ 1 ohm, 2 ohm, 4 ohms if I connected in parallel and calculate the net resistance, okay, yes, this is 1 ohm, 2 ohm, 4 ohm. Okay, that means 1 by reciprocal, 1 by parallel is equal to 1 by R1 by 1 by R2 plus 1 by R3. Correct? 1 by Rp is equal to 1 by 1 plus 1 by 2 plus 1 by 4. That means 1 by R in parallel is equal to LCM of this one 4, 1 4s are 2 2s are 4, 2 1s are 2, 4 1s are 4, 1 1s are 1. That means 7 by 4. That means Rp is equal 1 by Rp is equal to 7 by 4. Okay, Rp is equal to 4 by 7, isn't it? Yes, that means 0.40. 7 how many are 40? 7 5s are 45, 35. Once again 5 is remaining. Okay, 0.5 ohm. The net resistance of the parallel connection of the 3 resistors is 0.5 ohm. That when number of resistors are connected in parallel, then the combined resistance is there, no? This is less than the smallest individual of resistance. The connection has so many advantages over series connection. What are the advantages of parallel connection and what are the disadvantages of the series connection? So, suppose if electrical appliances are connected in series, if one appliances, for example, second appliances was failed to work or it is not working, the other two also not working because they are on the same connections. The circuit is broken, so the other two appliances are not working. Whereas in case of parallel connection, if the middle one suppose is not working, other two work properly because the circuit will not broken because they are connected in parallelly. Am I right? Yes. And then connection of electrical appliances through series is highly impractical because different electrical appliances require different amount of current. But in series connection, the same amount of current is passes through each appliances. At that time, the different current requirement appliances get damaged. Whereas in case of parallel connection, if we connect the different current required appliances are connected in parallelly, there is no damages happen because current passes through each appliances is different. Series connection offers high resistance, parallel connection offers low resistance. That's why parallel connection in a circuit is more advantageous over series connection in a circuit. Now, you go to what are the difference between parallel connection and series connection. Now I make a tables, please note down. Okay, yes. See difference between series and parallel connection of resistor. In series connection, first one we should draw the diagram simply. Second one, R in series is equal to R1 plus R2 plus R3 dash dash dash. In parallel connection, 1 by R in parallel is equal to 1 by R1 plus 1 by R2 plus 1 by R3 dash dash, reciprocals of the resistance. Then this in series connection, single path of current go with single path. But in case here, current go with different path. So multiple path of current. And fourth one, current flowing through each component is same. They say no difference in the current. Current in each resistor getting same. But here voltage across the each resistor is same or each component is same. If one component is failed to work, other will not. Whereas in case of parallel connection, one component is failed, other will work. Then it offers high resistance, it offers low resistance. So the difference between these two is very, very important for the examination point of view. Okay, dear students, I will show one parallel and series connections model to you in the next video, and at that time we will come to the conclusion. At that time all your doubt become clear. Dear students, I will show one experiment about series connection and parallel connections, and at that time all your doubt become clear. I will show the experiment in next video very quickly. Okay, until take care, bye bye.